Okay, we're going to try this. This will be a trial run, and I'm going to pretend I'm talking to Tyler. Or Tyler Henderson while he's asleep. Or Connor. Anyway, I'm going to go through some of the problems on this practice test, and that way you can look at it during class. I'm just going to talk to that right there. And answer your own questions or try to. Okay, the first problem is the limit definition, and I think what I'm just going to do is just work them. That way you can figure it out. Maybe you can see them. I don't know. Now, I will say this. Don't make careless mistakes on your test because if you know, like number 1, that that the derivative should be 2x plus 1, then you need to make sure your limit definition says 2x plus 1. So anyway, you've got f of x plus delta x, which is minus f of x all over delta x. And then multiply that out. And I'll let you look for that a second. And then you cancel your stuff, so it's x squared, x's cancel. You can reduce everything by delta x, 2x plus delta x, and then, that's going to leave you 1 delta x plus 1 because of that one right there. Then don't forget to plug in your 0, so your derivative is 2x plus 1, which is what you should have gotten. Okay, number 2, you can find the derivative the way that you know how, howdy-hi, rewrite it, but you still got to use the limit definition. So, it would be 1 over x plus delta x minus f of x over delta x. I hope y'all can see that. And then I'm going to get a common denominator up top, so that's x times x plus delta x. Cross multiply x minus x plus delta x, and I'm going to go ahead and bring this into the denominator. So up top you have x minus delta x all over x delta x, x plus delta x. Your x's cancel, your delta x's cancel, and you can plug in 0 for delta x, so it is 1 over x times, when you plug in 0 right there, it just leaves you x, so your answer should be 1 over x squared. Number 3 should be 0, because pi is a constant. Number 4 should be 4x. I went ahead and took the derivative of that, but I am rewriting this one, so I hadn't taken the derivative of 5x to the 1/2 yet. So I have 4x minus power rule, 5 times your power, reduce your power by 1, and then rewrite. So 4x minus 5 over 2 square root of x. Bonus point would be getting a common denominator, which would be 2 square root of x. Cross multiply, which would give you 8. Add your exponents, so right here you got 1, and you've got x to the 1/2, so that would give you x to the 3/2 minus 5. So that would be an alternative answer. Number 5, you can either FOIL it, or you could use product rule, but I think you're good with that. 6 would be howdy-hi. 7 is sum and difference rule, so you have to take the derivative of each one. So I'm going to rewrite the first one. And I'm going to rewrite the last one, and I'm going to distribute. So that would be x to the negative 1 times x plus 1. So I'm going to just remember.
Students, can I have your attention, please? Anyone that is 18 or will be 18 by November the 1st and would like to register to vote, you need to report to the lunchroom. Please bring a pen. And you need to have your driver's license or the last 4 digits of your social. Anyone who is 18 or will be 18 by November the 1st And you would like to register to vote, report to the lunchroom. Also, at this time, I need the dance team girls to meet me in the front lobby. Thank you.
Okay, just so you're clear on what I did, I distributed that while she was making an announcement. So this is actually what you're taking the derivative of. Now, you could have left that last part, the x plus 1 over x, alone, and you could have done Hody High, but you have to take the derivative of each term. So, on this first term, I used the product rule, power rule, so I got 2/3 times -2 times x, reduce your power by 1, I'll fix it in a minute, minus constant rule, and yeah, so it's 1/3 times the derivative of x, which is just 1/3, plus 0, because that's just your constant, so you don't have to put anything there, plus 1 derivative of x, and then I took the derivative of this, which is bring your power to the front, times your x, reduce your power by 1, and now I'm fixing to rewrite it. So that gives me -4 over 3x cubed, minus 1/3, plus 1, minus 1 over x squared. Now, you could get a common denominator. You do not have to. But if you do, it would be 3x cubed would be your least common denominator. This one already has it. Hold on. I had not gotten it yet, but he didn't have a chance to do it until this block because he taught first and second. But I did text him to him. You can. He's in the field house or in his office.
Okay.
Sorry, I thought it would be easier to just stop it. To just walk away and do a new video. So this one already has the -4. This one is missing the x cubed, so you need to multiply this by x cubed, so that just gives you x cubed. This one doesn't have anything, so you need to multiply the 1 times 3x cubed. This one is missing a 3x, so you would multiply by a 3x. Now, you could combine these two terms, and then you have your answer. But you do not have to get a common denominator. You can leave it just like that. On number 8, you need to do the product rule at the very beginning. So you have 2x times the derivative of cosine plus cosine times the derivative of 2x. That's the first part. Minus, you can use the product rule on 2 sine x, or you can just use the constant rule, which is -2 times the derivative of sine, and then just clean it up. But if you'll notice, this and this are going to cancel, so your answer should just be 2 sine x. On number 9, you should be good. Number 10 is going to be a lengthy one, but you can either use product rule. What I probably would do would be distribute the problem 3 times. I'd multiply it out. On number 12, x cubed plus c. If c is a constant, that just means it's a number. It could be 7, it could be 8, it could be 9, whatever. You've got to take the derivative of it, so of course it would just be 3x squared. 13 is kind of like number 9. You have to take the derivative of each term separately, or you could get a common denominator from the very beginning, and it would be t to the 4th. Your t squared is missing a t squared, so it would be, no it's not, it would be t to the 6th up top, my bad. Let's see, let me write this down. If your common denominator is t to the 4th, this one is missing the t to the 4th, so you have to multiply this by t to the 4th, and makes it t to the 6th, minus. This one is missing 2 t's, so you have to multiply the 1 by t squared. And this one has everything, and then you could do Hody High. So you could use your sum and difference rule on 13 or do Hody High. 14 is 8x cubed minus the constant rule, so it's 3 times the derivative of cosine, which is negative sine, plus the derivative of sine, which is cosine. So number 14 is easy. 15 is product rule. 16 is Hody High, and I'll do that one. It's bottom times the derivative of your top, which would be cosine, minus your top times the derivative of your bottom, which would be negative cosine x. I hope I don't make a mistake on this, over ho squared. And no, don't say 1 minus sine squared, because you'd actually have to FOIL that out if you wanted to simplify it. Up here, you need to do the distributive property. So you've got cosine x minus sine x, cosine x. Right here, you need to do the distributive property. So that is positive cosine x minus plus sine x cosine x, and it's all over ho squared, but I'll fix it in a minute. Those cancel, and you have like terms. You have 2 cosine x's over ho squared. So that's your answer on that one. 17. Oh my goodness, that's one of those that you might have to, kind of like we did yesterday that y'all complained about. I would just, well, it's not that bad. I would just use power rule. 1/2 x to the negative 1/2, bring your power to the front, times your x, reduce your power by 1, minus, bring your power to the front, times your x, reduce your power by 1, and then you just need to clean it up. 1 over 2 square root of x, plus 1 over 2 square root of x cubed. And you can leave it x to 3/2, x to 1/2, I don't care. 19 is product rule. 20. Let's see, you got to evaluate